Okay, so in this video, we're going to take a little bit of time to lay some foundation for our next section. So we're going back to the appendix, the back of the book, to A4, Appendix 4. We're going to go over a couple of things today, 2 learning targets. So this appendix is getting us ready for our section on rational expressions. So a rational expression is the quotient of 2 polynomials. So basically it's a fraction set up with a polynomial on the top and bottom. So numerator, denominator are made up of polynomials. So that's what we're doing in this section, just to review some of these things to get us ready for our next section, 2.6. So our first learning target for today is I can find the domain of a rational function. So we've already done this before this year, so this would be a review. So let's review the groundwork of finding domain of a polynomial. So to do that, the domain, first of all, is a set of all real numbers, and that's that fancy R that we use to represent all real numbers, unless it's specifically restricted. So all real numbers, unless restricted. And restrictions are 2 cases here. Our first restriction is that the denominator, so the bottom part of this fraction, cannot be 0. It cannot equal 0. Why? Because division by 0 is undefined. Our second restriction would be the contents of a square root, so what's under that square root must be greater than or equal to 0. Why? Well, because the square root of a negative number is imaginary and not a real number there. Okay, so how do we do this? Well, if you have set up as a fraction here, then you would set the bottom part, the denominator, equal to 0, or not equal to 0, because we don't want it to equal 0 here, and then solve for x, and that would be your restriction. If we have a square root, we're going to set that whatever's in the square root greater than or equal to 0 and get x by itself. And then finally, we'll write our answer as all the reals and then list the restrictions and interval notation. Okay, so keep the success criteria handy. Just put that to the side, and as we work through these problems, we'll refer to this piece of paper. Okay, so here we go. We're on page 40 of our note packet, and we're going to go over these 2 learning targets today. So I can find the domain of a rational function. That's what we just went over. So that's right here. I can find the domain of the function. So I've got my success criteria right next to me, so I can reference it. And I notice that all 3 of these are rational expressions. So all 3 of these have a denominator, which means that's the first restriction we talked about. Denominator cannot be 0. So let's go over these. So I know that the domain is going to be all the real numbers except for my restrictions. And this restriction follows the first one, denominator can't be 0. So I'll go down to step 3 of my success criteria, and I'll set my denominator not equal to 0, and then solve for x. So I'll add 4 to both sides here, and I'll get x cannot be 4. So the domain of this rational expression is all the reals except x cannot be 4. And then finally, I need to give the interval notation. So the interval notation is all the reals but 4. So how do I show that? So all the reals would be negative infinity to positive infinity. So I want to show negative infinity to positive infinity, but not 4. So I'm going to do this like this, negative infinity to 4, union or and 4 to positive infinity. Remember, parentheses means that this 4 is not included. If it was a bracket, that would mean it's included. So the parentheses shows that the 4 is not included. All right, let's try number 2. So same thing, this is the restriction of domain cannot be 0. Or the denominator cannot be 0, not domain. Domain is all the reals, but denominator cannot be 0. And then to solve for x here, I have a quadratic, so I'm going to factor it. So what are the factors of negative 3 that add to 2? That would be positive 3 and negative 1. So x plus 3 cannot be 0, and x minus 1 cannot be 0. So x cannot be negative 3, and x cannot be positive 1. So my domain, all the reals except x cannot be negative 3, 1. And now interval notation looks like this. Negative infinity to negative 3, and negative 3 to 1, and 1 to positive infinity. All right, pause the video and try the last one on your own. All right, so you should have gotten, for that one, you would set the denominator, so all the reals except for the denominator cannot be 0, and then you would solve that and you would see that x cannot be negative 2. And then you would give your domain from there, like so. All right. Okay, so that concludes our domain section. Let's go on to simplifying these rational expressions. So this next section, so let's get back out our success criteria. So now we're down here at the learning target. I can simplify a rational expression. So to simplify these, first we need to state the domain. The domain needs to be given when we're simplifying. So we would use the success criteria above here to find step 1, the domain. And then we factor completely. We reduce it by dividing out the common factors, making it as small as possible. And note this, sometimes you have to factor out a negative 1 in order to get those common factors to match up. And you'll see that in the homework. And then lastly, write the simplified answers with the restrictions being the domain there. All right, keep this handy so we can refer to it. So here's our next learning target. I can write the rational expression in simplest form. So we're going to simplify these. So first of all, you're going to give the domain. So the domain of number 1 is all the reals. And then if you set this denominator equal to 0, you would find that x cannot be 0. So there's my domain. Now I'm ready to go ahead and factor completely. So for this one, it can't really be factored, but we can go ahead and go down to step 3 by reducing it. So 20 over 15 can be reduced by 5, so 4 over 3. And then for my exponents here, remember when you're dividing these, you subtract the exponents. So 5 minus 2 is 3. So that goes away, and this becomes x to the third. So final answer, 4x to the third over 3 with my domain. All right, you try number 2 on your own. Okay, let's check that one. So that can be reduced by 8 here, so 1 and 4, and then x goes away, and this becomes x squared. So 1 over 4x squared, and then of course all the reals except x cannot be 0 here. All right. Okay, let's look at number 3. So number 3, I'm going to find my domain first. So this is a denominator that cannot be 0. So all the reals except x cannot be positive 3. Because if I do x minus 3 cannot equal 0, add the 3 to the other side, there would be your domain. And then we're ready to simplify. So for this one, we're going to go ahead and we have to factor this one. This can be factored. So I can take a 3, the GCF of 3 out of the numerator. And then the denominator cannot be factored, so I'll just write that down. And now this is one of those problems where you have to factor out that -1. So look at the success criteria step 3. The little side note there says it may be necessary to change the sign of a factor by factoring out a -1. And this is what we have to do here. So it's almost there. 3 minus x and x minus 3. They're not quite the same, but if we factor out a -1, then they will be. So I'm going to factor out the -1, which makes that a -3. 3 times -1 is -3. And then what that does is it changes the signs of these. So this becomes positive, and then that 3 becomes negative, making it x minus 3 like what we need. And those cancel out. And now I'm just left with 3. So -3 for all the reals except x cannot equal positive 3. All right, try number 4 on your own. Okay, so number 4, I'm looking at the domain first. So this is going to be all the reals except y cannot be positive 1. And then I'm going to go ahead and factor what I can. So this is a difference of squares, so that's y plus 1, y minus 1 over y minus 1. Divide out the common factors, and then I'm left with y plus 1 with my domain there. Okay, try 5 and 6 on your own. Go ahead and pause the video. Try the last 2 on your own. All right, let's look at this. So this would be all the reals, and then if I factored this, I would see that y cannot be -4 or positive 4. And then I have to factor the whole thing. So I'm going to factor the top, and then the bottom. Divide out my common factors, and I'm left with my answer there, of course, with my domain. All right, last one. Let's see how you did on that one. So the factoring of this one, so this one's kind of different. This is a trinomial, and this is the a term here. -3 is your a term. So this is the kind of factoring when you have to multiply 8 times -3 and you get -24. And then you find the factors of -24 that add to -10, which would be 2 times -12. And then you would rewrite this so that -10 is replaced with 2 and -12x. So that looks like this. 8 plus 2x minus 12x minus 3x squared. Group them. And now find the GCFs of each group. Common factor is 4 plus x. And then left over is 2 minus 3x. So that is factored for the top. Now we need to factor the bottom. So the bottom one's a little bit easier because it's a trinomial when a is 1. So I'm just looking for the factors of 4 that add to 5, so 1 and 4. Now, finally, it's factored completely. And now I can divide out my factors. But before we do that, let's find the domain. So remember, the domain is the denominator cannot equal 0. So we have our denominator factored. And so I see that it's going to be all the reals except for x cannot be -1 or -4. So there's my domain. And then go ahead and divide out the common factors. Remember, addition is commutative, so they can flip, and so those are actually the same. And you're left with your final answer there. All right. Hope you enjoyed this lesson. Now you are ready to do your homework.